Hello children, welcome to my channel. I am Padma. I am running a school by name Sri Sai Sarvani Vidyapit. I am running it since 2003 and with more than 30 years of my experience, I have already done SSC Telangana State Syllabus 10th class mathematics textbook. I have solved each and every sum of that in the channel Sarvani Math Made Easy. And also, now I want to do science. Science, physics, and biology. One by one, I will do. So I hope I'll be clear to you. And that too, I am doing only your previous SSC questions. Even in that Sarvani Math Made Easy, I have done SSC questions right from 2015 to 2025, both March and June papers. Similarly, I wanted to do this up to this 2026. Of course, this June paper is going to come up to March. I wanted to do, so I'll be doing that for you, children. So I'm starting now with your first chapter. The first chapter is reflection of light at curved surface. In this, 2 marks questions. I hope you know about your examination pattern. Your pattern is 2 marks questions, 4 marks questions, 6 marks questions, and objectives you will be having. Now, I'm discussing 2 marks questions, children. The first question here is, you see, does focal length of a spherical mirror changes when it is completely immersed in water? Predict and write the reason. So, first of all, what is focal length, children? Already you know about this, just a small drawing will help you further to children. So if you take this as the lens, this is the coated surface, this is principal axis, this is pole, and this is F. How did you get F? When the rays from infinity touch that mirror and when they get reflected back, the point through which they go. This point, this principal focus or focal point. This distance is called as focal length. Focal length. So usually we represent it as small f. Now the question here is, what is the question? The question is, reflection does not depend upon the surrounding medium. Hence, the question is, does the focal length of a spherical mirror changes? This focal length which we are discussing about, this focal length, is it going to change when it is immersed in some medium, whether it is in water or oil or any other medium, and the mirror is immersed? Because this figure which I have given, it is in air. So suppose the same mirror is immersed in water, or if it is immersed in oil, is this focal length going to change? That is the question, children, whether the focal length changes. Actually, we know that for a normal mirror, if you take, this is a mirror, this is the shaded one. So we know that this is incident ray and this is a reflected ray. And this is a normal ray. You know that incident ray, reflected ray, normal ray. This is called angle of incidence. This is called angle of reflection. Now the question is, when this is a plane mirror, this is a curved mirror, children. So here this is a concave mirror. So when this concave mirror is dipped in water or in any other medium, whether this focal length changes or not. Actually, the answer for it is, what is the answer, children? Reflection does not depend on the surrounding medium. What is meant by reflection, children? Here you see, this is the mirror. Ray is incidenting and it is coming out. in the same surface, this we are calling it as reflection. So this reflection does not depend upon the medium. Well, let it be in water, let it be in oil, or let it be in any surface, in any medium, this part will not change. So reflection does not depend upon the surrounding medium. Hence, focal length of a spherical mirror does not change when it is immersed completely in water. So definitely, because we say that reflection is not depending upon the surrounding medium. If reflection is not depending, then definitely the focal length of the mirror also will not change. That is the answer for this first question, children. And the second question is, write any two uses of spherical mirror. This is the question. Any two uses of spherical mirror. So two uses means I have taken here two lenses, two mirrors, concave mirror, one use of concave mirror and one use of convex mirror, because they have asked only for two. So I have taken these two. So the first one is concave mirror. What mirror I have drawn in the earlier figure is concave mirror. So concave mirror is used to observe magnified image of tooth. What is the meaning of it? Say, if you go to the doctor with any tooth pain or infection in in your tooth or something, then what the doctor will do? The dentist, the doctor who is dealing with our teeth is called dentist. So, what does the dentist will do? He has to observe your tooth in an elaborated, enlarged manner. He can't just look into your into your mouth, and he can't judge what has happened. So he need an expanded image of it. So for that, what he does, he sees the image of your tooth by using concave mirror. So that what happens? This concave mirror will magnify the image. Whatever is its size, it magnifies the image, so that what all the defects that that particular tooth is having, the doctor can identify and he can treat accordingly. So dentists use this concave mirror. Then in vehicles, convex mirror. Concave mirror is used by dentists. Convex mirror is used in vehicles. What for? As rear view mirrors. I think you know about what are rear view mirrors and all. In that rear view mirror, the people can see, the driver or rider will see who is coming from the back, which vehicle is coming, and how, which type of turn he has to take, how he has to be safe while riding or while driving. That is possible with rear view mirror. So all the rear view mirrors contain convex mirror. Now children, let me talk about the third question. State the differences between virtual and real image. So what is the first point? It is formed when two reflected rays meet. What is that? Real image. So let me explain you with this figure, children. See here, this is a concave mirror. Object is here. This is incident ray and this is a reflected ray. And one more ray is passing through focal point, and it is getting reflected like this. So this is one reflected ray, this is another reflected ray. These two rays are meeting at a point. If you draw a perpendicular, this is image, this is object. So how is this image is formed? Real image, it is formed when two reflected rays meet. See, these two rays are meeting at a point. So this is a real image, and virtual image is formed. Virtual image is formed on extending the reflected rays back. What is this extension? Let us see here. See, this is the figure, virtual image figure. The object is placed between P and F. You have learnt about ray diagrams, children. Between pole and F, object is placed, and this is the ray which is coming in, passing through C. And you know the property of this ray. This ray, it itself incident ray and also reflected ray. That is why these two arrows are in this direction. This is incident, this is reflected. So this is the line passing through the center of curvature, which has no reflected ray. It itself is the reflected ray. Next. And another ray from this edge of this object is incidenting here to the lens, mirror, and it is getting reflected through F. Now these two rays will never meet, but on extending backward, see, they are meeting at a point and you are getting an image here. This is considered as a virtual image. So on extension only you are getting. That is why the definition is virtual image. It is formed on extending the reflected ray backwards. And real image is always, it forms an inverted image. See children, this is called inverted image. This is erected, this is inverted. Always in real images, inverted image only you will be getting. And in virtual image, of course, it is erected image. It forms an erected image. So these are the two answers for this problem, for this question, children. So once again, the differences between the real and virtual image. Real image is formed when two reflected rays meet. Virtual image is formed on extending the reflected rays backwards. And always real image forms an inverted image and virtual image always forms an erected image. Next. Fourth question, which property of the concave mirror is used in making solar cooker? So you know, but as the name indicates solar, it is something dealing with the sunlight. So a concave mirror converges the reflected rays obtained from rays at an infinity. See, figure I have drawn, children. You see. This is a concave mirror. These are the incident rays. Every incident ray is passing through a single point. See, these are incident rays. They are also passing through it. This point, they are passing through a single point, that is called as point of convergence. Or convergence means the point where they meet. That is principal focus we usually say. So the object, so a concave mirror converges the reflected rays, and how these reflected rays are obtained? They are obtained from the rays at infinity. Rays at infinity means these are the parallel rays that we will be drawing. These all are the rays at infinity. They all are getting reflected rays. All the reflected rays are converging at a point. So the concave mirror converges the reflected rays obtained from the rays at infinity. The point of convergence is called focal point. This principle is used in making solar cooker. Let me give an explanation for it, children. Why is that principle used? See, these all are incident rays which are coming from the sun. As these rays are coming from the sun, each and every ray has got its own energy because they are coming from the sun. But what is happening? All these rays are reflecting and meeting at a point. That means each and every energy of these light rays are pointing, focusing at a single point. Then definitely here the energy will be much more than all individual rays. That is why a lot of energy is there here. If you keep any utensil with some food item, it starts cooking. You all might have played with magnifying glass. Keep magnifying glass, focus it towards sunrise, and keep it up on the paper starts burning. You didn't lit any fire there, but it starts burning. The reason for it is earlier all the rays were traveling parallel to each other, so their energy was separated. But the moment you have made them to pass through a particular lens, that is a lens. Here we are talking about mirror. When the rays are passing through, here in this case through the mirror, all the reflecting rays are converging. Converging means they are meeting at a point. So all the energy of all these rays are focused at a particular point. So a lot of energy will be there. So there, if you start cooking any item, keep any utensil with any food item, it starts cooking. So this is how solar cooker is made, children. Next, fifth question. Predict and write the reason why the value of the distance of the object U is always negative in the mirror equation. This is what we are going to talk about. Fifth question, predict and write reason why the value of the distance of the object U is always negative in the mirror equation. So let us see what is mirror equation. Mirror equation is mirror equation. This is 1 by F is equal to 1 by U plus 1 by V, where F is focal length and U is object distance and V is image distance. This you know pretty well, children. You have learned. Now in this question, predict the reason. Predict and write reason why the value of distance of the object, means object distance U, is always negative in the mirror equation. Here U is always taken as minus U. The question is why? Why are we taking it as negative in mirror equation? This is something dealing with your sign conventions. So what are these sign conventions, children? See, when you have got a mirror like this and an incident ray, an object is here and the rays are coming in this way, this is incident ray and this is the distance of the object which you are considering it as U. We measure it from here to here. That means what? Incident rays. I hope you are able to see. See, this is incidenting ray. So the arrow is this side. But when you are measuring from the pole, you are measuring from in this side. The zero of the scale, you will keep it here. That means these two directions are opposite. Therefore, always we will be taking U as negative. This is the reason why you are taking U value as negative. The same answer is given here, children. So let us go through it. The object distance is measured from the pole to object. This is opposite to the direction of incident ray. I told you, no, this is opposite to the direction of incident ray. See, this is incident ray. This is the direction of incident ray and you are measuring in this direction. Both of them are opposite. So, opposite to the direction of incident ray. Hence, the value of the distance of the object U is always negative in the mirror equation. I hope I am clear, children. I am going to stop today's portion up to here. In the next class, I will be doing the next part.